Welcome to this online class. I'm going to present a paper. And this presentation is going to major on the general information about the pump. And without wasting time, I would like to share presentation slides. And then we can be able to look at them in detail. Remember, we said that there is something that is called a water pump. And water pump is always used to energize the water molecules so that water can move from a region of lower elevation to a point of higher elevation. Otherwise, you are required to use the pump, that is the gravity, and gravity will always move water from a region of higher elevation to a region of lower elevation. But if opposite is the requirement, then you need to use a pump. When we are using a water pump, we are saying that these are the devices that convert the mechanical energy to hydraulic energy, meaning that the rotation of the impeller, as we're going to see, is the one responsible of converting or energizing the water molecules, and water molecules is going to flow towards a different point. So they are used, that is the water pump are used to move water from a lower point to a higher point with a required discharge and pressure hand. So that is the main purpose of these of the pump. This chapter is going to deal with the basic hydraulic concept about the water pump. Initially, we said that water pumps are classified into two main ways, that is turbo hydraulic or kinetic or rotordynamic pump. We said that we talked about the centrifugal pump, we talked about the propeller pump and the jet pump. And then we are supposed to know that water pump are also classified into positive displacement pump. And in this case, we are going to give us the reciprocating pump and the screw pump. When we are discussing about water flow system in a pump or flow in a pump, this classification is based on the type of the flow system water is entering and leaving the system. For example, when you have the radial flow system, the water leaves the impeller in a flow direction, meaning that the water that is entering and leaving, they are forming an angle of 90 degrees. Then from there, we need to know that there is something that is called the axial flow system, as you can see from the second diagram. This is whereby water is moving, or water is moving in the same direction, that is the incoming and the outgoing water is flowing in the same direction, as can be seen by this diagram. Then in the third diagram, the mixed flow pump is in between the radial and the axial flow pump. Another thing that I want us to discuss is the internal, that is the schematic diagram of the basic centrifugal pump. As you can see from that diagram, you can see that there is something that is called the inflow. Water is flowing in the system. This is the internal part of, or the eye of the impeller. The curved are the veins of the impeller, while the impeller is the whole interior part, the one that is shaded, is all of them is called the interior. Then you have the casing or the housing or the volute. Then you have the discharge point. Discharge is where water is flowing through, that is out of the system. So after the rotation of the shaft, as you can see from diagram number B, it is going to rotate the impeller. It is going to rotate the impeller because that shaft is connected to the eye of the impeller. And therefore, that eye of the impeller, because it is connected to the veins and everything, it is going to move, or it is going to allow the movement of the impeller. And as the impeller is revolving or rotating, it is going to scoop out water by use of its vein, and then water is going to be discharged through the delivery section of the pump. Then from there, we need to discuss about the schematic diagram of axial. In the axial, water is that the pump is only moving up and down, and therefore water is coming in and out in the same direction. That is, there is nothing much that we need to discuss there. Then the screw pump, as the screw rotates, it moves. That is a revolving shaft fitted with the blade rotates in an inclined trough and pushes the water up through the trough. The same case there. Then we have the reciprocating pump, and in the reciprocating pump, a piston sucks the fluid in a cylinder into a cylinder, then pushes it up, causing the water to rise. This one I'm going to show a video that you can check pertaining to that. And before I do this, I think it is good that we first of all check that video. It is very important that we have the videos that can be able to assist us in this discussion, because when we have visualization of what we need to know, then it becomes so easier for us to be able to apply the knowledge effectively. So the first video I'm going to give, it pertains to what? To the single stage centrifugal pump. Just let me share the video so that you can be able to visualize what is happening in this kind of so this is the video I want to share. First of all, this is a centrifugal pump, and you can see that on this end we have, this is the motor. The shaft is in between here and here, the motor and the pump. The pump is this one. So the water will enter through this section, the one that I'm pointing, and then it leaves through this direction, the one that I'm pointing. So water is coming in like this, then it meets the impeller and it moves in that direction, forming an angle of 90. Let's see. That is the motor that we are talking about. It is the one that is going to energize the shaft, and then the shaft is going to rotate the impeller. That is the shaft that is connected to the motor. As you can see, it is also moving. That is the impeller that is enclosed in a volute. You can see the way it is rotating. You can see the way it is rotating. And you can see that those reddish things that are inside, they are curved veins to scoop out water. And then you see we have the volute, the casing at the top. That is the operation system, the way it is happening. That is how we can be able to get different parts of the different parts of the impeller. That is not the impeller, but another thing that we discussed last time, before I forget, is something to do with the pump affinity laws, the pump characteristic curves, and the like. So this one we are going to see later. But generally, what I was about to say is that when you look at the pump characteristics, when you look at the centrifugal pump, it has the shaft, it has the motor, and it also have the rotating shaft. So this section is the discharge point where water enters through the eye of the suction, and therefore, as you can see from this arrow, there is a rotation that is taking place. The vans of the impeller, they are curved in nature. Then we have the casing of the volute. Then as water moves in this direction, it enters the discharge pipe, and then it is scooped out or forced out of the system. Then from there, I think you can see that the incoming fluid in and fluid out. Then we have the impeller. And that is what you can see. Yeah, that is also the same thing. This is just a discussion of what the impeller is. You can see we have the incoming water from bottom, and then it meets the shaft rotating, and that's the impeller rotating, and then it is forced out through the external point. Yeah, and these are some of the information that you need to know. That is, we have different parts. We have different parts of the system, like we have the casing, we have the suction pipe, the delivery pipe, the shaft, the driving motor. These are the components of the pump. Those are the components of the pump. Okay. We can reach at that point. Next time we shall discuss more pertaining to this. Thank you. Thank you, and be blessed.